Okay, so let's chit chat about the lab. One of my longer titles.
Yeah, that's the right way to do it. Up we go.
So, what you're going to do, there's like different parts to this lab. Okay? So the first part is going to be a titration like you have done before. So here's what you've got. What you're going to do is you're going to take 25 milliliters of 0.1 molar acetic acid, add universal indicator phenolphthalein, whichever the indication of your choice is. You're also going to, so in here, you're going to have 25 milliliters. Straight acetic acid, just straight acetic acid. Boom, you're on. Here. Use that volumetric pipette so that you can measure out exactly. That way you don't have to. This is why it shows 25 milliliters, because of the fact that you have 25 milliliters volumetric pipettes. Okay, you don't. You just graduated cylinder. No, this is why you have volumetric pipettes. So you're going to add sodium hydroxide, just like you've done before, and you're going to measure the pH, and you're going to want to generate a curve. Okay. So you know that you have, the beauty of this one is that you know what the concentrations of the acid and the base are. Okay. So now you're at least going to have a better idea. So if you have 25 milliliters of a 0.1 molar solution of acetic acid, and you're adding 0.1 molar solution to it, how much sodium hydroxide should it take to neutralize it? 25. About 25. So I would go by twos until maybe you hit like 20, and then start going by maybe like ones. And the reason that you really need to find out where that pH is because of the fact that you, as Natalie noted, you only have one piece of pH paper, okay? But you're going to end up drawing 3 pH curves on the same paper so you can compare them. So the reason that you want good data is because, and you're only going to do this on the first one, okay? You're going to have the curve, boom, and this is going to be a supplemental set of questions. You're going to find that midpoint of the equivalence point. You're going to find half the equivalence point. You're going to find the pH, and you're going to find the pKa. But you only need to do that one time, because the other two are going to be buffered solutions, so it won't work anyway. You can't do it if you try. Okay? So, first curve, boom. This is the only one you can use to even find the Ka value. So this one you have to have some good data. Now, that's the first one, straight up. There you go. The second one. On the second one, down there on calculation number 1, you're going to add exactly 0.373 grams of sodium acetate into the 25 milliliters of your acetic acid. Okay? Now, I say 0.0373, and your scales measure out to 4 decimal places. Don't spend 15 minutes trying to get the last half granule on there to get exactly 0.0373. Okay? Use that value for your calculations, but when you actually measure that out, don't sit there and spend 10 minutes trying to get that. Now, I'm not saying get 4 grams and call it good, okay? That's a bit much. But get something close to 0.037, okay? If you're a little bit above, a little bit below, that's cool. But when you do the calculation of the pH, use the 0.373, okay? So that's going to be your second titration. So your first titration is just acetic acid, just straight acetic acid. Boom, that's it, okay? The second one, you're going to start with 25 milliliters of acetic acid, but then you're going to add the sodium acetate to it. What you have to figure out is what the pH of that is going to be, okay? But again, on calculation 1 and calculation 2, you have not added any hydroxide, okay? This is just straight ionization of acetic acid. So on calculation 1 and calculation 2, at the bottom of this white page, the introductory page, you will add hydroxide to it, but this is not the point of the story at this point, okay? You have not added any hydroxide. So your reaction, like on calculation number 1, a couple ways you could do it. You could just go, oh, pH equals pKa plus the log of your anion concentration divided by the concentration of your acid, okay? Acetic acid, you know what the pKa value of that is. The trick here is that you have to find the anion concentration, okay? Once you get that, because you already know what the concentration of the acid is, I gave you that. That's 0.10. The only thing you don't know is the concentration of the anion. Now, calculation 2 is a little sketchier, okay? But on calculation 2, I want you, on this one, up down there on step 9, it says, determine the mass of sodium acetate needed to obtain a second buffered solution with a pH of exactly 6, okay? So on this one, here's the difference between calculation 1 and calculation number 2. Calculation number 1, I gave you the mass of sodium acetate, and you have to figure out what the theoretical pH is. Calculation number 2, I told you, hey, this is the pH that you want. How much sodium acetate do you add to make that happen? Okay? Now, let me give you a hint. On calculation number 2, you want to end up with a pH of 6, right? That's where you want to end up. It's acetic acid. The pKa of acetic acid is 4.74. Plus the log, right? Now, just think this through. This is your anion concentration over the concentration of your acid, right? Which number has to be bigger, the anion concentration or the concentration of the acid? Why? Why? Yeah, this whole thing has to be a positive number when you take the log of it, so that when you add it to 4.74, you get 6. So you know your anion concentration has to be bigger than the concentration of the acid. So that's the advantage of really understanding the Henderson-Hasselbeck equation, because you can look at that and go, okay, hey, I need to end up at 6. Cool. All right, well, what's going to happen there? It's got to be bigger, right? So that way when you do the calculation, you know if it's right. So when you get done with calculations 1 and 2, ask me. I will tell you if it'll right or wrong, especially on that second calculation, because if the mass of sodium acetate is calculated incorrectly, then you're just dead in the water right from the beginning, okay? So you can ask me on calculation 1 and calculation 2. So here's what you're going to do. You're going to take that 0.0373 grams, add that to the acetic acid, titrate it with sodium hydroxide, boom, there you go. You don't have to get as picky at that equivalence point because you're not going to find the Ka value off of it. So just kind of get close, okay? Still back it down. I'm not saying add 10 milliliters at a time and go, okay, hey, we got it. We added 10 and 20 and then we measured the pH. No, okay? At least go in 2 milliliter increments. And then the third graph that you're going to have is where you're going to start off with that pH of 6. So what's going to happen, and then you can do this in different colors. That would make it easier for me to grade. You can do solid lines, dashed lines, stars, glitter if you want. Okay? Don't do glitter. I hate glitter with passion. It's just an environmental train wreck. It's just a bunch of microplastics that ends up in the groundwater. But anyway. So, I hate glitter. If I were king for the day, I would ban glitter. Okay? True story. So, what's going to happen when you get done, you're going to have 3 different curves all on the same graph, okay? Obviously, which one should be the lowest initial pH?
The one without a buffer.
The one without a buffer, okay? The one without a buffer. So today, yes, this is going to be a 2-day lab. So don't get... If you can get today, if you can get the first titration done, then then you can take and get that graph drawn. If you can get the pH, if you can get that first titration done, so you can get that graph drawn, Get that done today, that would be great. If you want to do the calculations for 1 and 2 today, great, but don't worry about doing those titrations, okay? So get calculation 1 done, because that's going to take the longest time to draw on the graph, because that's when you have to find the Ka and Ka. All right, I'm done. Let's go do science.